Okay, so I'm going to go through the quiz B practice. The first question asks, which of the following points is a solution to the system of linear equations given by what's there? Now, a point is a solution to a system of linear equations if you plug it in and get left-hand side equals right-hand side. So I'm going to make a little check area for option A. I'm going to plug it into equation 1 and equation 2. In equation 1, so for option A, equation 1 says 0 minus 1 plus 3 times negative 3 equals negative 4. So we have negative 1 minus 9 equals negative 4. That's false. So it can't be option A. Okay, move to option B. Now it has to be true for both equations. If we found it was true for equation 1, we'd also have to double check is it true for equation 2. All right. Option B, we're going to replace x with 1, y with 5, z with 0. So when we do this, we're going to get 1 times x, so 1, and then minus 5 plus 3 times 0 equals negative 4. So 1 minus 5, that's negative 4, is equal to negative 4. That's true. But we also have to check 2. We have to make sure it satisfies the second equation. So we have 3 times 1 plus 5 plus 3 times 0. Oh, sorry. No plus. There's no plus anything there. I'm looking at the wrong equation. There's no z component, so I don't even have to introduce the 0 there. Equals 5. So this now says that 8 equals 5. That's false. So it can't be option B. We can cross that one out. We'll go to option C. Plug into equation 1 first. Get 1 minus 2 plus 3 times negative 1 equals negative 4, which means, so we have 1 subtract 2, so negative 1. Negative 1 plus negative 3, that's negative 4 equals negative 4. That's true. But we have to check equation 2. So 3 times 1 plus 2 equals 5. 5 is equal to 5. True. So they're both true. Thus, option C. Now, for fun, we don't need to check D or E, but we could. If I check D, equation 1, we're going to have 1 minus 2 plus 3 times 0 is equal to negative 4. Negative 1 is equal to negative 4. That's false. So it can't be D. And then option E, the first one, we get 0 minus 5 plus 3 times negative 3 equals negative 4. Negative 14 equals negative 4. False. So it can't be E. Okay, question 2. Which of the following matrices is not in reduced row echelon form? So what I'm going to do for each of these matrices is I'm going to check each of the leading ones. The first non-zero number in its row, make sure it's a 1. But leading ones are circled here. So in that first matrix, we look above and below each of the leading ones. We only see zeros. That's good. We cannot introduce additional leading ones. For example, I cannot put a leading 1 inside column 2, because that would mean finding a spot to put a 1 here, one of those entries, and it's not possible to do that without making that top left leading 1 unhappy. Likewise, inside the fourth column, we can't put a leading 1 there. And the last column, we can't put a leading 1 here. Not possible to do that. So those 2s and 3s and that 9 might bother you, but there's nothing you can do about it. We're stuck with that. That is a matrix that's fully row reduced. So it can't be option A. Now we go to option B, leading 1, leading 1. Above and below the leading ones are 0. And then we cannot introduce additional leading ones. So it can't be B. All right, now I'm going to circle the leading ones. Option C. And above and below them, everything's 0. And we can't introduce additional leading ones anywhere. Okay, and then for D, we have a leading 1, another leading 1. And this is the answer. I'll tell you why. Rows of zeros should be at the bottom. Must be at the bottom. Okay, and then the last one. So that's the answer, D. So I should bubble in. Be a good example for you, bubbling and stuff. And then for E, we don't need to do E, but I'm going to circle all the leading ones. The other ones in there are not leading ones, so I'm not going to circle them. Above and below all the leading ones are 0, so that's great. And those other ones there, they could be 7s, they could be 2s, they could be 3s. It wouldn't change anything. Actually, any number inside, I'll show you. Any number inside this block here. Actually, no, even better. Any of these numbers in that block that are currently 0s and 1s there, they could be anything. And that matrix would still be fully row reduced. So again, to fully row reduce a matrix, you don't need to reduce everything down to 0s and 1s. Sometimes it's not possible. What you want to do is you want to maximize the number of leading ones that can be created, and you want those leading ones to be happy. Okay, question 3. For what value of k is the system of linear equations corresponding to the augmented matrix below? Oh, there's some grammar issue. For what value of k is the SLE corresponding to the augmented matrix below? Will. It should be will. The SLE corresponding, we have a 2-parameter family of solutions. So 2-parameter family means 2 columns are missing a leading 1. But we already have one such column. I'm going to circle the leading ones. So there's no leading 1 here. Okay, so there's one parameter. I'll put a t there. Oh, actually, I'll do what is more traditionally done. I'll put a little s there. That's an s, not a 5. I know my s's and my 5s look the same. Okay, there's an s for my first parameter. Now I want a second parameter. Well, there can't be a parameter in any column except column 2 and potentially column 4. So we want to prevent a 1. So we want to prevent a leading 1 here. Okay, so my first step is I'm going to do a row reduction step. I want to make that last leading one in purple there, this one, I'll make that last leading one happy. I'm going to replace row 4 by row 4 minus, let's see, I need that 2k to disappear, so minus 2k times row 3. So k is some number, like 3 for example, so it would be minus 6 row 3 if k was 3. So row 1's not changing, 1900 k squared, 8k, 0, 0, 1, 0, 0, 7k, 7. Row 2 is not changing, 0, 0, 0, 1, 3, 6, that's not changing. And then row 4 is the only one that's changing. 0 minus 2k times 0, 0. 0 minus 2k times 0, 0. 0 minus 2k times 0, 0. 2k minus 1 times 2k, 0. And then 12 minus 3 times 2k, so 12 minus 6k. And then the last entry, 6k squared minus 2k times 6, so minus 12k. So I'm going to check. I want to prevent this from ever being a leading one. It will never be a leading one. If equals 0 and need right side equals 0, 2. Otherwise, no solution. So if we have 0, 0, 0 all the way across, it's not going to be a family of solutions. There'll be no solution. So 12 minus 6k is equal to 0. That means 12 is equal to 6k. That means k is equal to 2. So k equals 2 will cause a 2-parameter family of solutions. Okay, and then E would be the answer. For no solution. There's no value of k that you could use that would prevent a solution from existing, because you want 0, 0, 0, 0, not 0. The number that makes the bottom right entry equal to 0 is 2, but it also makes the right-hand side equal 0, because 6 times 4 minus 12 times 2, so 6 times 4, 24, 12 times 2, 24, 24 minus 24, that's 0. And then option A, all k not equal to 2, that would be for unique solution. Okay. Fourth question. Fourth question asks us if D is equal to 3AB minus 2A, where A and B are given there, find the 2, 1 entry of that new matrix D. So D is equal to 3 times AB, so 3, 1, 2, 0, 7, 0, 4 times B, negative 2, 3, 7, 3, 4, 3, 1, 5, negative 11, and then minus 2A. Okay. So before actually doing any matrix calculations, I'm going to make sure the size makes sense. We have a 2 by 3 times a 3 by 3 minus a 2 by 3. So when you compute those, you're going to get a 2 by 3 minus a 2 by 3, which is going to be a 2 by 3. So I'm going to write down the entries that are going to be inside this matrix. We're going to have D11, D12, D13, D21, D22, D23. And then think about the dot products that we need to complete for D21. We want this entry here. So to compute that entry, I'm going to take the dot product of row 2, column 1. I'll say D is equal to this. So then D21 is going to be, don't forget the 3. I need the 3 there. And I need the -2 times the 7 there. I'm doing this the fast way. So 3 times 704 dot -2, 3, 1 minus 2 times 7. So 3 times 7 minus 2, -14. 0 times 3, 0. 4 times 1 plus 4, minus 14. So -14 plus 4, -10. -10 times 3, -30. Minus 14, so -44 is the answer. If you want, you can do all the dot products. All 6 dot products, but we're only asked for 1 entry, so you don't need to do it all. Okay, question 5. What value of k does this matrix not have an inverse? To create an inverse, here's the process. You put the original matrix A. Next to it, you put the identity matrix. So a 3 by 3 vertical line, 3 by 3. And then you row reduce the left-hand side to create the identity matrix on the left. And whatever gets created on the right is going to become the inverse matrix A inverse. To prevent, I'll put sabotage process by preventing A goes to identity on the left. So that's the part we want to stop. We want to make it impossible to reduce the matrix A to the identity matrix. So here's my 1, 0, 0, 0, 1, 6, 0, 3, 2k, and on the right hand side 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so I'm going to make that leading one. I'll circle the leading ones. This leading one in the middle there is unhappy because of the 3 below it. My first step is I'm going to replace row 3 by row 3 minus 3 row 2. So row 1 will stay the same. Row 2 stays the same inside this step. Maybe we don't need to go any further than this step. And then row 3 becomes 0 minus 3 times 0. 3 minus 3 times 1, 0. 2k minus 3 times 6. So 2k minus 18. and then 0 minus 0, 0 minus 3 times 1, negative 3, and 1 minus 3 times 0, 1. Okay, and now we can prevent A goes to identity. We can prevent that 2k minus 18 from ever turning into a 1 by setting it equal to 0. So 2k is equal to 18. K is equal to 18 divided by 2, which is 9. So option C. Okay, and then last multiple choice. Consider the system of linear equations given that horrible mess of a's to i's constants unknown. Find the value of y in the solution to the SLE if we're told that the coefficient matrix with the A, B, C, D, E, F, G, H, I, the inverse of that is given by that matrix there. This is a gift question. Since AX equals B has solution X equals A inverse times B if A inverse exists. Okay, so our solution vector x, y, z is equal to A inverse 4, 5, 12, negative 1, 4, 3, 6, 6, 0 times B. So I'll highlight what's B. B is this over here. That's B. So times 1, 2, 0. So this says x is equal to 4, 5, 12 dot 1, 2, 0. First row with the column. So we get 4 plus 10 plus 0, 14. Y is equal to negative 1, 4, 3 dotted with 1, 2, 0. So we get negative 1 plus 8 plus 0, we get 7. So there it is, option A. And then Z, which we don't need to answer it, but I'll get it anyway, is 6, 6, 0 dot 1, 2, 0. So 6 plus 18 plus 0, 24. Okay, and that's it. Question 6. Okay, long answer, part B. Part B, 1A. Write the augmented matrix for the SLE. Okay, so we're going to put this into matrix form by just writing the coefficients in the correct locations in the matrix. So we're going to have 4, negative 2, 1, negative 8, 8, negative 1, 4, 6, 3, 4, 6, 0. So there's no x4 in the third equation. So there's a 0 coefficient there, and then the right-hand side, 12, 6, 6. That's 1 mark for part A. Part B, completely row reduce the matrix found in part A. So my first step is I'm going to do a row swap. I'm going to swap row 1 and row 3 because there's a leading 1 there. So I'm looking at this leading 1, and it's not very happy because it wants to be at the top if it can be at the top. So if we do this one first move, we'll have 1, negative 1, 3, 0, 6. And then row 2 stays where it is, negative 2, 4, negative 8. Oh, sorry, I'm reading the misreading it. Negative 2, 8, 6, 6, 6, and then the row swapped. New row 3 is now 4, negative 8, 4, 4, 12. Okay, and this is a unhappy leading 1 because below it does not see zeros. Above and below should all be zeros. So my next move is I'm going to take row 2 and replace it by row 2 plus 2 times row 1. Row 1 will stay the same inside this step. So 1, negative 1, 3, 0, 6. And row 2 becomes negative 2 plus 2 times 0. 8 plus 2 times negative 1, so 6. 6 plus 2 times 3, so 6 plus 6, 12. And then 6 plus 2 times 0, so 6. And then 6 plus 2 times 6, so 6 plus 12, 18. In the same move, I'm going to replace row 3. I want to zero out that 4 that's there, so I'm going to replace that row 3 by row 3 minus 4 times row 1. So 4 minus 4 times 1, 0. Negative 8 minus 4 times negative 1, so negative 8 plus 4, negative 4. And then 4 minus 4 times 3, so 4 minus 12, negative 8. And then 4 minus 4 times 0, which is 4. And then the last entry, 12 minus 6 times 4, so 12 minus 24, and negative 12. So now that leading 1 is happy. Next, I'm going to create a leading 1 over here, where that 6 is. So I'm going to take row 2 and divide by 6. Every entry has to be divided by 6. 1, negative 1, 3, 0, 6, and then 0 over 6 is 0, 6 over 6 is 1, 12 over 6 is 2, 6 over 6 is 1, 18 over 6 is 3. And we might as well at the same time take row 4, or row 3 rather, and divide by, let's just divide it by positive 4. So we'll have 0, minus 1, minus 2, 2, and minus 3. Okay, next. So I have this leading 1 here in the middle, but it's unhappy because above and below it doesn't see 0. So my next step is I'm going to replace row 1 by row 1 plus row 2. So I'll have 1 plus 0, negative 1 plus 1, 3 plus 2, 5, and then 1 plus 0, 1, and 3 plus 6, 9. Row 2 is going to stay the same, 0, 1, 2, 1, and row 3 is going to become 0. Oh, row 3, we're going to do row 3 gets replaced by row 3 plus row 2 as well. So I'll have 0 plus 0, negative 1 plus 1, negative 2 plus 2, and then 2 plus 1, 3, and negative 3 plus 3, 0. Oh, and I forgot to change this, the right-hand side there. So I add those. Oh, the middle line didn't change, sorry. Okay. All right, so that's where we are now. It's almost done. We have 2 happy leading 1s. Happy, happy, and this over here needs to be a leading 1. So I'm going to take row 3 and divide by 3. So 1, 0, 5, 1, 9, 0, 1, 2, 1, 3, 0, 0, 0, 1, and then 0 divided by 3 is still 0. Okay, and then I'm going to take row 1. So this bottom right leading 1 is now almost happy. Looks up and it's like, okay, I'm a 1, but come on, there's some non-zero numbers above there. Let's fix those. So row 1 is going to be replaced by row 1 minus row 3. Row 2 will be replaced by row 2 minus row 3. 1, 0, 5, 0, 9 minus 0, 9, 0, 1, 2, 0, 3 minus 0, 3, and then the last row. Okay, now that's fully row reduced. I'm going to put a little t label here. That's a parameter. Since there's no leading 1 in column 3. And we can't create a leading 1 there. So this is done. Part C, using your matrix in part B, state the solutions to the system of linear equations. Now, here we go. Row 1 says x1 plus 0x2 plus 5x3. We said that that's the parameter column, so 5t, plus 0x4 equals 9. So x1 is equal to 9 minus 5t. Row 2 says 0x1 plus 1 times x2 plus 2 times t plus 0x4 equals 3. That means x2 is equal to 3 minus 2t. Parameter in column 3 says x3 equals t, and then row 3 says 0x1 plus 0x2 plus 0x3 plus x4 is equal to 0. So that means x4 is equal to 0. So that's your solution to the system of linear equations. It's a straight line in 4 dimensions.